a lot, Wayne. Thank you so much for the opportunity. I remember what is it now? 5 years ago, I got an opportunity to speak at the Sydney Observatory, and we had
Yeah,
just accomplished our first expedition. And happy to talk about further activities that we've been doing ever since then.
it was pre-COVID, wasn't it? It's hard for me to remember some of the
Yep.
stuff that happened before that,
Yep.
but that's right. But that's at least we got some continuity to find out how things have progressed. Because I understand a lot more's happened since then. We're going to find out
Yeah.
how.
Cool. So I'll just give a quick overview and then share my screen and jump right into it. So I think I've since then moved back to India, worked for a few years, and then right after that was at NASA JPL for about a year and a half, working on sample collection systems for deep space robotic missions, and up until a couple of years ago, moved to Perth here in Western Australia to work at Fugro. So my day job and my geographic location has shifted around, but I've continued to remain on the board with Mars Society Australia and find ways in which we can, continue a sustained partnership in India to support analog research and analog studies. And um, ever since we started, the response and the priority for analog research in India has also changed. Back in 2015, 2016, when we used to talk to the Indian Space Research Organization, there wasn't a lot of interest or enthusiasm because it wasn't directly lining up with their interests. But as some of you might be keeping up, that there's been a lot of recent developments and achievements in the Indian space program. There have been a few missions, successful ones, successful soft landing on the lunar south polar region, um, having a rover deployed and conduct scientific operations on the surface. And they've got ambitious plans to build a human spaceflight program as well as do lunar sample return and subsequent missions. And about a year and a half ago, I was contacted by ISRO to help contribute towards their um, and astrobiology, planetary science exploration, and how they could leverage analogs. And I was like, this is it. This is finally the time when the work that we started about 8 years ago might come in use. And we've been trying to explore ways in which we could directly work in the Indian space ecosystem. And many times, going in with an Australian affiliation was not very helpful because there's regulations around which you have to work. You need to have an Indian registered entity and those sort of things. So with all of those things in mind, about a year ago, we incorporated a startup in India called Protoplanet. It's essentially built to be um, like a body of experts, which is coming in to provide research consulting and also kind of provide training to universities in India. So that's kind of the background of Protoplanet before I jump right in, because the presentation was more of a Protoplanet deck. It was important for me to give the motivation and the reason why we've tried to navigate and find a way in which we could work in India. So with that, I'll just share my screen and talk about how what that really means for India. So if someone can just confirm that my screen share is coming through fine.
Yes, good, Sid.
Awesome. Thanks, Andy. So essentially, like I mentioned, we've established Protoplanet. It's registered in Bangalore in India, which is the space capital of the country, to deliver space exploration training for institutions and public engagement. And it's broader than just a Mars focus. It's focusing on things like Earth exploration and experiential, field training for students and research faculties. That involves essentially analogs, and we've been registered as a space tutor. So what that means is that ISRO has a program in which it, you know, identifies and selects organizations through which it can conduct its education and public outreach, its capacity building. So we've partnered with them now in an official capacity to be an ISRO space tutor to do that. And that's essentially to help us, bring in ISRO experts as and when needed for projects that we run in India. So why are we needed? India, as you are aware, it's a hugely populated country. There's limited opportunities are preventing the growth and preparedness of the student pool and the planetary science community in India. So because there's thousands of colleges and universities, there's limited opportunities for them to get the right exposure. And through Protoplanet, which is essentially a network of experts who are contributing in their individual capacity onto projects, we're able to try to plug some of that gap. And as the program is Indian space program is kind of advancing, they are looking towards the research community to provide high quality research proposals and science definition, site selection for missions, and payload development, and so on and so forth, for high impact scientific contributions. And right now, the pool of people who can contribute to that is quite limited because they haven't had that level of training and exposure to work on these kind of missions. So our job is to essentially find ways in which we can accelerate some of that. Like I mentioned, there's been a few successful missions over the last decade or so. There's been the Mars orbiter mission about 11 years ago now, in 2014, which was the first successful orbit insertion for a probe in its first attempt by India. And they're also working on a Mars landing mission concept right now, which is still in a study phase, but is moving forward and has been publicly acknowledged. With regards to the lunar exploration, just a little less than 2 years ago, ISRO successfully landed on the surface of the moon. That was the Chandrayaan 3 mission, and it was essentially a orbiter lander rover mission architecture that is now being continued through Chandrayaan 4 and collaboration with Japan on a joint mission called LoopX. So ISRO is looking at what kind of technologies it needs to develop and what mission planning and payload design it needs to undertake. And with regards to the human spaceflight mission, this is one of the most ambitious projects that ISRO has ever, taken on. They've been sanctioned for funding to develop both human-rated crew capsules as well as the space station called Bharatiya Antariksh Station, or BAS. That it will essentially build. India will have its own space station in the 2030s. I think 2028 is when they're aiming to have the first portion of it launched into low Earth orbit, and eventually it has plans to have Indian astronauts landing on the surface of the moon by 2040. So all of that has been kind of laid out, and they're looking towards the community to come forth and support ISRO as it's building out this architecture. So that was one of the main motivations, and then the other one was, of course, from the analog side of things. We've been engaged in a lot of astrobiology focused analog trips into India, particularly into Ladakh in the high altitude Himalayan region. And there have been other locations across the country that have been identified but have not yet been completely explored. And the value of the analog sites and what does that mean for um, research groups or technology development groups or even for the agency has not been very well fleshed out. And because we have been doing some work in this area, and when I say we, I mean individuals like myself, collaborators within Mars Society Australia, flew from NASA, from US, and in Europe, and some in India. So essentially, it was this loose group of people who we've managed to essentially bring under the umbrella of Protoplanet to essentially help work with the Indian Space Research Organization to find ways in which how analogs can immediately contribute towards these missions. So I guess just to summarize what the background of Protoplanet is, it's registered in India. It's a kind of a gateway for organizations outside of India to also work with ISRO. It's set up in a way that it makes it easier, to allow for that collaboration. And right now, the two areas in which it's focusing on is microgravity and analog projects. And this is essentially basically based off the priorities that the Indian Space Research Organization has set up. So because of the expertise and insights that have been gained since 2015, the individuals who have been identified and brought as part of the expert network provide that subject matter expertise. And it's essentially a facilitator or an aggregator of scientific kind of groups to work on some very projects that inform both from the microgravity low Earth orbit side of things or remote analog side of things. And lastly, there's a component of us doing education and public outreach, where Protoplanet is bringing a team of artists and storytellers together to help, find creative ways in which we could document all the information around the projects that Protoplanet undertakes and how that could be converted into, digestible forms of content, whether that's artwork or storytelling or, just in video format, and that can be kind of brought out. So broadly speaking, these are the different areas within which the network is focusing upon. In terms of projects, I'll focus on Spaceward Bound India. That is one of the main areas, I think, in the topic for today's talk. So since I mentioned analog, so this year we are undertaking Spaceward Bound India. Some of you might be familiar with Spaceward Bound. It's essentially a program that originated at NASA Ames Research Center, and it's a teacher training scientist, like a multi-purpose field expedition that originated at NASA, was held at different locations in the US, like the Mojave and others. There were versions of it which were held in Australia, for example, in the Pilbara, and also in New Zealand and other parts. And in 2016, I had led the Spaceward Bound India expedition, and people such as Jonathan Clark, Annalie, and others from Mars Society Australia were helping coordinate that expedition. And they've decided to use the same format and with permissions from the folks who've started Spaceward Bound as a community. We are essentially taking the responsibility to take Spaceward Bound back into India and use that format to demonstrate how analogs could be useful to scientists, to engineers, to remote operators, and also for educators. So that's mainly one of the decisions that was taken to bring that in and keep the momentum going in terms of the work that we started. So, like I mentioned, one of the strengths that we have are all the individuals who are part of the team, and it's a pretty big team. It's been growing, and this is essentially like a knowledge pool that we are creating. And for each of the projects, we are able to bring in people as and when required. This is just a subset of people who are part of the Protoplanet expert network. Now, I do want to say this, that they're all on board in their individual capacities. Their institute affiliations mentioned here are only for indicative of where they are currently. And we have, Protoplanet has been signing on institutional partnerships as and when required. But these are individuals, either active or retired, or academics, or research people, or in startups, who are essentially, contributing in their individual capacity onto the projects as and when required. Previously, for Spaceward Bound, we've gone a little bit of an unconventional route to get support to run the expedition. So in terms of programmatic support, NASA Ames Research Center mainly has been helping us provide the right kind of framework and material to, design the program. Permissions and field access has been granted by the local government in India, in Ladakh, which is where the expedition takes place. We've had Tata Motors, which is a major automotive company in India, to provide sponsorship and vehicles, and also a film crew to cover us. Similar support from companies such as GoPro and National Geographic. And of course, like, I've not mentioned Mars Society here because I essentially was part of that. So I wanted, this presentation was essentially to show people outside of Australia who kind of been contributing to Spaceward Bound in different ways. So this year, Protoplanet is working with the Human Spaceflight Center at ISRO on both the projects that we have undertaken. So with regards to microgravity, we have been selected by ISRO to provide a report. So we're working on a small consultancy project with their help to essentially inform what sort of microgravity ground infrastructure and human resources they would be requiring to inform their upcoming missions. This is a report which will be internal to ISRO. It's essentially them seeking out some of the insights of our experts who have worked on the ISS, for example, who got that microgravity experience. And this is a start to a deeper collaboration that we want to set up with ISRO, so that essentially helping build the microgravity user community in India. So that's folks not just from academia, but also from industry, who could essentially come forth and help inform what sort of infrastructure should be set up, established on ground for those microgravity experiments or operations, as well as help inform what kind of laboratories need to be set up on the station, what sort of life support systems would be required by astronauts, for example. So there are these different topics that eventually we'd like to work with them on. But to start with, to kick off the work this year, it's essentially this report which will help capture some of that initial recommendations from our side to them. In terms of the analogs, we're actually working closely with, again, Human Spaceflight Center, the University of Ladakh, which is just recently been established about 3 years ago, and the Union Territory of Ladakh, so the state government there, to carry out the terrestrial analog research program, which is the Spaceward Bound India. It will be carried out in July, and we've secured the government approval to conduct this, as well as establish analog testing infrastructure in place, which I'll talk about. There have been other strategic partnerships that have been formed to realize the analog project. So, for example, companies such as Spartan Space, which is a French company that is working on developing lunar habitat mock-ups and other infrastructure for in support, and for the European Space Agency and CNES, the French Space Agency. So they are partnering with us to support some of the infrastructure requirements in Ladakh. Companies like GoPro, of course, have been formally with us. They'll be providing us camera and also a crew to help document the work. RSAT is actually a subsidiary of ResearchSat, which is an Adelaide-based company. They are building microgravity payloads and platforms. Cyberspace is a company based out of the US. It's a startup that is also working in that domain. For the network right now, we're working with Satcom Industry, and in terms of the research and mentorship part, that's where the Mars Society Australia and Blue Marble Space, both organizations which have been pretty fundamental in supporting all the work that we've been establishing in Ladakh over the last 8 years, is kind of coming back in. So even though Protoplanet is a new entity, it's building on a lot of experience that has been gained by its its members. We've had over 4 international expeditions through Ladakh. Over 50 scientists have been involved, 100 students mentored, different kinds of technologies that have been tested up there. There's been all kinds of experience, both from, ranging from field operations, logistics, sample collection and transfer for science, that has been gained, that is informing, how we can leverage that environment. And in terms of research output, there's been, a healthy number of research publications that have come out of there, and also students who have actually graduated with work that they conducted, in that environment. And the work's been supported in different ways. So, like I mentioned, there's been sponsorship, but there's also been small government grants and registrations that have, helped form this. And in many ways, I think, the legacy that we set up has helped seed some of the astrobiology research or even the community building efforts, in India. And this is something that we are quite proud of, because a lot of students in India today hear about us and the work that, as a community, that we have been doing to help enable that. So we've been having national level meetings. This was all mostly pre-COVID, where we had some in-person meetings. There was efforts to build that astrobiology community in the country, and we've been contributing towards a space roadmap for ISRO twice at least in the last, I would say, 7-8 years. And there was a paper that we published as well that talks about how astrobiology as a driver can help connect the public, scientists, and space missions. It was a advocacy paper for ISRO to formally kind of take on astrobiology, which it finally is doing right now. Maybe to some small percentage due to the work that we had been doing so far, but we kind of knew that it was only a matter of time until which they would come to realize the potential and the consequence of how astrobiology and analog research could inform some of their missions. In the past, alongside Mars Society Australia, the other organization, Blue Marble Space, which is a US-based nonprofit, has actually been supporting a lot of the online workshops, in-person field workshops, and classroom workshops, both targeted towards students as well as working professionals. So we've actually, gained a lot of insights through these activities in terms of what the response is, what is the current readiness of scientists and universities in terms of how they approach these topics. And it's been very healthy to see that the numbers who are interested has only been increasing over the last few years. So it's actually quite interesting to see that there's been a lot of good response, for these kind of research activities within the country over the last few years. A lot of the work, like I mentioned, has research output at the core of it. We do ensure that the activities that we conduct are directly informing university projects, thesis projects, and collaborative efforts that bring people together. And over the years, the knowledge of the site, the actual locations, and in terms of understanding what activities could be conducted has only grown over the last few years. So the first three expeditions were held in Ladakh. The fourth expedition was actually held at the Mars Desert Research Station, where we selected a group of individuals that Annalie led as crew commander. And the whole objective of that crew was to actually gain operational experience and understand, the kind of the laying the foundations for an analog station in India, in Ladakh. So that was a prep kind of expedition where people were going in to get that level of hands-on experience. In terms of how the research that we've been doing in Ladakh has been contributing overall, um, these are just some kind of snapshots of few of the papers that have been relevant. I think the work that has been done has been acknowledged and cited by some really high-profile, high-impact science people, like David Deamer, who's one of the authorities on hot spring astrobiology, has cited some of the work that we've done, and there have been other examples. And this only is a matter of pride for us because most of the times the world, if you have to look at the atlas of analog sites across the world, there were very few locations in India, actually let alone India, in South Asia or even the Asia Pacific region, which would show up. And one of the efforts that we are very proud of is that our work has been acknowledged and cited by the overall community. And that's really one of the efforts to identify it, help preserve it, and promote it sustainably to the wider community to come in and utilize. These are just some snapshots of some of our previous expeditions that have taken place. They've been conducted before Protoplanet existed under different host institutions. So whether that was Amity University in the past or remotely led by Mars Society Australia and locally managed by BSIP, which is one of the Institute for Paleo Sciences in India. So there have been different ways and means in which we've done these expeditions. And what you're seeing there is essentially the different kinds of activities that do take place, which is collecting, environmental data, whether that's from the analog, the analog lakes, the soils, and the air quality, air environment, as well as subsurface measurements of mapping of the permafrost. So all of these are the different kinds of activities that we've done, and of course field training. And this has actually been one of the most useful, where we've noticed that very few universities in India actually have, the ones that teach natural sciences have an active, field program, a training program. And this is something that we felt the students were really attracted towards and wanted to get, more and more experience of. So that that field traverse for students has been super useful. That site that you see there is Sokar, which is a high altitude glacially fed lake that's slowly drying up and receding. And I haven't spoken about Ladakh and why it's important as an analog. So Ladakh is an early Mars analog. It's similar to what Mars might have been like about 2 to 3 billion to 2.5 billion years ago. And it's kind of a time capsule that helps people understand how the landscape has been evolving. The conditions that we have there in that high altitude of over 4,000 to 5,000 meters above sea level allow for these niche extreme environment ecosystems to exist. Whether that's the salt-rich crusts around the salty lake, glacially fed lake, or the permafrost deposits that are pretty rare on our planet, or the boron-rich hot springs, which have these different kinds of microbial mats and deposits, silica-rich deposits around them that essentially preserve biosignatures over time. So all of this is literally within 100-kilometer diameter. So it's a very interesting site because it's relatively accessible. It's a 45-minute flight from New Delhi, and then a few hours drive in either direction. You're in some of the most remotest parts of the world. So it's accessible for scientists to get in and out of. And it has a diversity of sites in close proximity that helps scientists understand what it can do. So it's a very complex ecosystem that's still not been completely well understood, but it's a location that is also affected by tourists. So we're also very conscious of the location that we go to, and we are working with the local government to ensure that we can provide that kind of enclosures and have people protect those locations for long-term use for us as well. Some more previous achievements from Ladakh. So I use this slide to essentially talk about how analogs are important for an entire space mission's life cycle. So one example is on the left side, where in one of our expeditions in 2016, that image that you see there of a dust devil forming and lifting up salt from one of the salt lakes was something that caught the fancy of a couple of our participating scientists. And over a cup of tea on a hot afternoon, looking at it, they started discussing about how Venus, early Venus, when it was in a habitable condition, might have had similar occurrences where salt might have been lifted up, into the dust with the winds, and then transported up microbial samples up into the clouds. And that led them to work on a hypothesis-driven paper, which talks about potential life signatures in the clouds of Venus. All to say that there are observations, natural observations that can be made in the field that actually can lead to hypotheses, which might lead to experiments being designed and payloads. And on the right side is a payload that was brought in by Dr. Javier Martin Torres. He's currently in University of Aberdeen, and he's the PI of the Habit instrument, which was initially selected to fly as part of the ExoMars mission for Europe, and is now, I believe, slated to fly for a Japanese mission. But they were able to bring in a flight hardware prototype into the field and actually test it there as well. And we've also taken up a team of students who designed a analog rover. They built this during COVID in very difficult conditions, and essentially took it up. We had it field tested in one of the shorelines of Sokar, and gave them, firstly, the operational training in terms of what it means to actually test things remotely without having enough spare parts or a lab or a workshop that you can rely on, and also operate in conditions where static discharge is really high, very dusty, very temperature extreme kind of environments. And they were able to accomplish like some traversability tests and capture some environmental data as they kind of went through it. But all to say that that level of capability was achieved over time. So you see, group of students, and this was literally after 5 to 6 sleepless nights where things were breaking down as they're taking it up. And the window of opportunity to do these tests was also limited because there was all these kind of windy conditions that develop and make it really hard to work in that kind of setting as well. So one of the motivations for us to actually set up an analog outpost there is to actually support these kind of activities. So for people to be able to do that, similar to the Mars Desert Research Station here. So I mentioned the recent crew. Annalie led a team of 7 individuals, 6 individuals, I think. Yep. So they trained at MDRS and explored different kinds of activities that they could actually bring to Ladakh and help carry out there as well. And that brings me to Spaceward Bound India. So this is essentially just a representation of what the dome would look like. It's going to be a geodome, about 8 meters diameter, that'll be set up for the season, close to the field site, and then dismantled by the end of season. We'll have about 30 participants who will go in with science, engineering, and education goals. The teams actually coming together quite well. They've been divided into subgroups, broadly categorized into either lunar planetary sciences or human-centric. It's been closely directed and led and coordinated by the ISRO Human Spaceflight Center. One of the reasons why we are seeking their support is because we understand strategically that all activities that would be conducted in that site would have them be pretty much core to what activities need to take place. Having said that, not to say that they are the only ones deciding what or does not get tested, but we are relying heavily on them to inform us in terms of what activities they think would be really useful, because they are the ones who will be funding a lot of the activities and programs in the near future. So this is essentially what the program would look like. We've finalized the dates just last week. So once the original Spaceward bound team confirms their attendance, there might be a few slots available, which we might post out for people to be able to join. The reason why we offered it originally to the original Spaceward bound team from 2016 was because we wanted to go in with people who were experienced with Ladakh, who've done analog research, and essentially minimize the amount of risk and time we would be spending to essentially bring new people up into speed. But having said that, after this first expedition has taken place, we do foresee having a call out for more and more participants to come forward. We are exploring the possibility of perhaps doing a second team later into the year as well. But coming back to the day-wise itinerary, normally you land into New Delhi, take an overnight flight, and then early morning next day you fly to Leh. Because you're landing at 3,500 meters above sea level, you essentially are required to undergo acclimatization, which is essentially just rest, sleep, and not be too mobile, just kind of be in place and then let your body get used to the fact that oxygen is now at 50% rather than at 100% at sea level. Once that's done, during those days, there's a bunch of different meetings and preparations. And then the whole team leaves for Sokar, which is a 4 hours drive south of Leh. And that's the Sokar site. What you're seeing on the left side is a representative image. And we're setting up the camp there. There'll be essentially about 4 to 5, broadly speaking, different activities that will take place either inside or outside around the habitat outpost that we're setting up. And once those activities have been conducted, everybody packs up. So essentially, we'll have 2 full days after the day we reach there, and then we come back to Leh. And then after a day, there's a 1-day workshop that's being worked out at the University of Ladakh, which will have ISRO in participation, and essentially an opportunity to discuss the activities that were just conducted and what future activities could be kind of held. So that's the plan for this year. It's being kept really tight and focused just to ensure that we're able to do a successful demonstration of what we've been doing so far to all the right stakeholders, but also allow for us to build on that and plan out longer analog activities. So I mentioned Ladakh University, so they're our partners to help enable the whole program. And they've recently been established, but actually have come up in a very good way, in a very fast manner. They've got facilities in place that can support a lot of future activities as well, both from the field science side of things or field robotic side of things. We're actually in talks with them to set up a robotic test yard to support analog research on campus as well. And the fact that the students on campus, there's opportunities for us to actually do extended operations even through the winter and not have our team be there throughout the year. So I guess that's where we are currently. We're in the phase of doing those monthly tag-ups for the science groups, finalizing those meetings. We're in the process of, also simultaneously working out the requirements for the actual habitat that will be set up. And the activity, the hab will be set up for about 3 months. The expedition will be a 12-day one towards the start of it. But we're also in the process of working out the different outreach activities that might take place later in August and September. And then we essentially close up and pack up for the season and then prepare for next year. And this is my last slide, which is essentially us doing a visual map of what kind of activities we foresee happening there. And to those of you who've been involved with analog activities, it won't come to much surprise to you. Essentially, you have the setup made in a way that you've got the science sites in mind, and you also have the different technology that you'd like to field validate, and those could be either worn by astronauts who are testing their analog astronauts who are testing their materials. You could have robotics, or it could be instruments and payload prototypes that are built and installed inside the hab, to support either direct measurements or samples that are being brought back into the hab and then measured out there as well. So in the first year, it's not going to be configured to be a residential kind of a facility. People will be using it as a day-use facility with bringing in equipment, doing the tests, and then we lock it up for the night. But eventually, as we build the fidelity on that, we be looking to build that. And it's a very fragile environment that we're in as well. We're very conscious of the kind of footprint we're leaving behind. So with all of that in place, SOCA might not be the actual location where a very high fidelity station might come up. It might be a little outside of, a little far away from some of those sites. But those are decisions and discussions to be taken once we are able to scope out, what kind of activities are being planned and who are the users of such a location. So I guess that's it. I will pause here for questions. And yep, thank you for the opportunity.
Thanks very much, Siddarth. Yes, I've got a couple of questions actually. So I'll ask mine and then we can get. I don't think anybody else is posting it. One question I was going to ask specifically on the habitats was, it looks like the dome, this one that you're going to be building, is obviously going to have a capacity for a lot more people. So you were saying 30 people. So as originally though, maybe you could only have half a dozen. Is that really the difference between the two? Obviously the size is one thing too. It's a lot bigger.
Yeah, sorry, I wasn't clear on that. So essentially, yes, the number of participants is 30, but the hab would probably be built out to only house about 7 to 8 or maybe up to 10 individuals at the max, at a time. Not everybody would be working inside the hab. Some of them would be, most of them actually would be outside, and only a few of them would be kind of seated inside. We foresee setting up some sort of a wet lab, a small robotics fit out, like a test work, almost like a little workbench for people to be able to do some modifications. And there's a team that's planning to build in a microgravity simulator, like a random positioning machine, with which they'd like to actually look at bringing some microbial samples and then suspending them and doing some. So essentially, I'd say about 4 or 5 of them would actually be inside the hab at any given point of time. And while they're not there, it's literally a sheltered environment. But one of the big things that worries people is handling samples, packaging them, labeling them. It's really hard to do that if you're in this outdoor, windy, dusty, sand-covered environment. It's essentially a space where people can do that. So to start with, those are some very basic, essential needs to have, like a outpost or a sheltered structure. But as we sort of build it out, we might make it modular. So next year we might actually come back by making 2 of those. There's much to be said about actually having very tall structures in windy conditions. So normally what we might end up doing is essentially having a limit on the height that we'd like to build. So essentially a 8-meter diameter would be probably about 4 meters in height, and we'd kind of cap it at that. We wouldn't go any higher than that. We might just have like different modules that are interconnected together in that kind of a condition. So there's all those different kinds of, how do we scale this up? How do we size this up? Discussions that need to be had. The first year will essentially just be something that can support 7, 8 people at a time inside.
Yes, it sounds like the environment's quite harsh and possibly a lot windier than the ones in the US, which is a problem. But the other problem you do have is that I don't think because of the altitude side, obviously the locals are going to be probably a bit more tuned to it. The idea of doing space evaluations is probably going to be a bit more complicated up there due to the fact of lack of oxygen.
That's right. Yeah, I mean, there's discussions about doing pressurized tests in that environment because you're already at 50% oxygen. So yeah, there's all those kind of things that we look at. So it'll be interesting to see what comes through.
Admittedly, it's actually probably closer to Mars than what it's because of the actual lack of oxygen. But
that's right.
It's got its own complications with the trying to do the spacesuit testing. So that's going to be one thing that's going to be a bit of fun over next few years. Okay, so I'll let Luz ask a question about Are there any other organisations doing this sort of work? Oh, competition. Okay. Oh, she wants to know how this particular organisation is like. Probably it's a bit of a background issue as to how it's come about.
Yeah, so I think we're essentially building our own. We've leased our own piece of land. Um, we're directly working to get the approvals and run this as an experiment. Maybe I gave the impression that ISRO selected us to build this. ISRO is not at this point of time investing any money in building any infrastructure in that analog environment. And I think when we were seeing a lot of groups approach ISRO for funding to do that, the question that they were asking back was, why do we need an analog? We don't even know what it's going to be used for. We certainly don't need it right now to build some of our missions. So can you tell us what it could be doing? It was met with complete silence because most people weren't prepared to be questioned back in terms of why they should be getting one. We knew why it should be building one, and we decided to take the risk of going in and investing in something that's not too expensive. It's something that's relatively affordable, that can be set up, established, and if it's not going to be used for research, it can be set up to do outreach in the future. So it's infrastructure that can be utilized for other means if ISRO doesn't need it, or if this whole experiment turns out to be not going anywhere and not enough users, we'll find different ways in which it could be done that. But eventually, yes, to answer the second part of the question, if ISRO decides to go in and build a habitat, there's a process normally that the government follows, pretty similar to the one here in Australia as well. They'll put out a tender. You'll have to submit a RFP, and then, they select you, and then you quote towards it, and then you get selected, and you kind of go ahead and build that.
But Project Planet, it's just by itself. You've participated in lots of other projects around the world, it seems. Yeah. So how do you sort of how do you coordinate? You don't have a building somewhere. You coordinate via a website, or?
So we have a team in place in Ladakh right now. We actually have individuals who are locals. This whole structure will be set up as a 3-month camp, essentially, if you think about it. And we actually have a close relationship with the locals, the owners, the traditional owners of the land as well. We've developed that relationship over the last, you can say, 7 to 8 years now. They are the ones whose land we'll be working on. We've leased from them, and they'll be taking responsibility to site manage it as well on our behalf. And they've been involved with a lot of our analog operations over the last several years. It's a new kind of a model, but essentially we do have boots on ground to help realize this project.
Where are you based? That's what I'm trying to understand the structure of it. How are you based? How do you coordinate your various people who give their expertise?
Slides, Lou. You might have to go back to one of the earlier slides to explain it, I think, because I think you were covering it earlier.
Is this repetitive? Okay.
Yeah, so we do have remote discussions. There's a team in place that's managing it. It's incorporated in India, so there's different ways in which we are coordinating the effort.
Mars Society is one aspect of it, but there's other organisations involved as well.
Yeah.
I suppose to add to that, how close is the University of Ladakh to where you're actually working, out of curiosity?
Yeah, so that's a good one. So Ladakh University is actually close to where Leh is, and the site where we're working is about 4 hours south of that. There is a discussion.
Okay, it's not like 5-minute drive. Okay.
Oh, absolutely not. No, it's pretty remote because the field site is far. There are discussions that we're having with Ladakh University where they have their own land. They have a lot of land themselves, and there's an opportunity that we might actually bring the structure to the campus as well and have it set up under their guidance. That's something that is being also explored. That'll actually make it a lot easier eventually. But the actual functional use case of it is to be in close proximity to some of our field sites, so ensure that as many people are able to use it. So those are things that are being worked out.
I think the great thing about it is that I know you've been doing this for, say, 10 years. As time's progressed, basically what's happened is because you've been successful in being able to achieve results, there's more and more people becoming involved with it because they can see it's working. So the advantage of you is that you just have to be patient, and it's growing.
Yeah, the main challenge has been there's a lot of capabilities, there's a lot of technologies, but there's been little context or a framed program within which it needs to sit. That's what we're working with this to set up, because once that gets set up, it becomes easier for companies to come in and universities to come in and kind of take ownership of things.
Yep. well, even if it's 4 hours away, it's still probably the closest university. So the great thing about that is that they'll probably eventually become more involved with it. I think that they want to see it as part of.
Yeah, I mean, in my understanding, it's one of the most accessible analog sites in the world. If you look at comparable sites, it's a lot easier to get to.
I think the only issue is going to be for some people the altitude sickness.
Yeah,
Some people don't do it as well as others, and it's just one of those things.
that's right.
Yes, talking about Zoom and Teams. Yes, I can guarantee that you're using a lot of Zoom and Teams based on what I'm saying. Yes, I think so.
That's right. Yep. Okay. So
There's no more questions. I'd like to ask another way if possible.
Oh, you can keep going if you want to ask another.
I'll show my ignorance again. But analogs, the term analogs you're using, I mean, I understand it as a practical application of what you want, rather than the digital VR, whatever. So, but is there anything else we can read into that term analogs as regards doing analog stuff?
Yes, that's a good question. Right now, when we use the word analogs, it's essentially an analog to off-Earth surface environment. So the fact that there's remoteness, there's environmental conditions that are as close as possible to what we might find. So whether that's the radiation, the atmospheric pressure, the dust, the static charge buildup, I guess a lot of things, and also regulate like geological surfaces, access to sites. So both from an environmental point of view, a scientific comparison point of view, and from an operations point of view, we're trying to leverage the location and help inform teams that are working either to test scientific instruments in the field, also to talk about technologies that are being developed for landers and rovers, to test concept of operations for missions that are looking at human missions or human, robot assisted human missions, so combination of those two kind of things. And when we look at the habitat itself, even though we're not right now building the habitat out to be like a mock-up of the inside of a Mars habitat, it does offer that opportunity for us in the future, where we might have a pressurized station that could be fitted out with life support systems, waste management, and all that kind of stuff. So that's something down the line. Right now, the analog component is mostly the external to the hab, so anything that has to do with EVA related activities.
But basically, they're doing geology because there's a lot of similar geology there. And also there's robotics testing, which is in fact what they were showing earlier. So those are the two main things. Plus also the dust devils. The dust devils are on Mars too. So I can see the similarity with the climate. As you've got similar types of conditions that might be creating those.
Yeah, and also to talk about the hydrothermal systems, so which are really interesting for astrobiology. So Martin van Ranendonk, he and I and Sudha Rajamani, we've been talking about places like Rotorua in New Zealand and Pilbara in Western Australia and Puga now in India. Puga Hot Springs is about an hour's drive away from Sokar. And these are locations where we look at the origin of life in terrestrial hot spring systems. And that's where Puga is one of the locations. It's a hot spring that exists at such a high altitude that exhibits these unique geochemistries. And the microbial mats that are found there are similar to what we might have found on early Mars because of those conditions. So in addition to the geology and the robotics, there's also the geochemistry part, which is super exciting.
Right, so it's in an ideal situation there, as you were saying. It's good. We're actually slowly getting it bigger. So, as you said, you'll got what is it? 6 weeks. How long is your actual program work? About 2 months or 6 weeks? How does it?
So we realized that setting up that habitat just for 12 days was just a lot of work. So the expedition itself will be about 10 days. But we aim to have set up for the rest of the season. So that allows us to do more outreach and engagement activities around it. It's also something that the Ladakh government is going to be using to kind of, point towards the fact that this is a special environment. It can help us study the climate. It can help us understand how we'll be exploring other planets. So it's essentially almost going to be like a flagship thing that people can look at visually from a distance as they're passing by, and refer to it as something that, they essentially talking to the preservation of the site and exploration, sustainable exploration of the location, for example. So that's actually something that Mars Society Australia is working on right now, to work out how we would be using it for the rest of the season after the expedition is over.
And you'll probably do another one of those ones that Emily did later on. So Julian's asked a question on does the altitude and elevated, affect the charged particle flux? Okay, yes, he's worried about what effect on electronic systems is going to be because of the altitude, and also that, I suppose you could say that the dust coming from the actual atmosphere itself. How does that
We've never done any measurements, but we've certainly seen things burn and short circuit. I think it's the dust and the really low humidity and the wind and the temperatures that cause it. I don't know how much the radiation does or not, but at least these are the things that do, and it's certainly a problem. I've been in touch with a few other people who run camps there, and they tell us that things like electrostatic buildup, charging and discharging of batteries, all of those things get affected in those kind of conditions. So it's definitely a concern that is an interesting concern sometimes, but it's something that we have to work around.
Going to be one of those things also. The type of problems that we're talking about here is probably something that will happen on Mars. So
yeah,
going to be important for folks try to probably work out what the effect is going to be. So it's a fair question, actually, what he's asked there. David, the question is, what is the level of public awareness and support of the Spaceward Bound program in India?
Yeah, it's actually been pretty good. Like in 2016, we got picked up by several newspapers. We were approached for newspaper interviews, and there were a couple of science education groups as well who covered us, and that gave us a little bit of a visibility. Generally, people are supportive of these things because they are looking at it as something that is helping India develop capabilities for the future. There's very little cynicism so far that I've seen. There's been a few groups that have tried to go in a rushed way and propose to do things. So we are very conscious about how we are setting up Spaceward Bound. We don't want to make it sound like here we are trying to leverage this environment, get all the information, and get out of there. We are very conscious about how we want to work with the local government, the people that are there, and also, we build in the fact that it's not just about space exploration, but Ladakh can actually help us understand how climate change is affecting the Indian subcontinent. We are literally seeing in front of us how the glaciers are drying up, and Sokard, one of our sites, is actually a site for that. Permafrost deposits us about methane leaks as well, and we are well situated to actually monitor that. So we are trying to find ways in which we can continue to stay relevant in the mainstream kind of public awareness as well, and help ISRO also, build a good reputation and image when it's kind of coming in to do these kind of activities. So far it's been good. Like we've actually received a lot of good support from the public.
So it seems to actually do climate change measurements too of the area over a period of time, and that's what will happen as well. So I'll find some benefit in that, definitely.
There's a question from Anne about where does everyone sleep. So it's a good question, actually, because we're not sleeping in the hab. We will be staying in a homestay. So there's a village about 10 kilometers away from our field site, and they've got, what can I call those? Like essentially hutments, but they're very basic. But they're not. It's not a hotel. It's not a resort. It's not a proper flat. But essentially, concrete buildings, ground floor buildings with toilets and stay spaces. Very basic. But,
and cots, cots rather than the floor or the ground.
That's right? So beds, and they actually are going to be setting up prefixed tents for us because this time it's a pretty big team. So once we go in there, they'll have residential kind of tents, and then there's going to be a huge community tent where everyone's going to be having their meals together, and that's pretty common for some of these far off locations where a lot of backpackers come in and stay in these kind of things. So that's where we'll be staying when we're close to the field. And then down at Leh, we'll be staying at a hotel. So we'll essentially be renting out the whole space. It's a nice sprawling campus that will allow us to sort of acclimatize, rest, and just kind of share notes. Those are the only two places we're doing. In the past, we have tried to fit in other locations in around Ladakh, but this time it's essentially just going to be those two.
Julian's got a question. Would you know if Solkar is the Rift Basin geological structure? Is that actually where you are? I'm assuming that's what, I don't know that context. I'm assuming that's what.
I'm not, unfortunately, able to answer that one. I can definitely look into it. Yeah, sorry, not a geologist here. But I don't even know what a rift basin is. Maybe I should look it up.
What type of structure it is? Yeah. Got to be a Mars analog, so we'll have to go back and look at that.
It's pretty close to the tectonic, so where the Indian plate and the Asian plate meet, and I do know that has been affecting a lot of the local geology of the region. I'm just not aware if it's a rift basin or not.
Yeah, essentially it's at the base of the Himalayas, isn't it? Really, this is where you're going to. It's really the foothills.
So when you drive from Leh towards Sokar, you actually pass through, you can actually see the place where the two continental plates are meeting. You can literally see it in front of you. So it's literally there. And there is a tectonic fault that passes not very far away from where Sokar is.
Right, so have you had any seismic activity at all when you've been doing those? Then, if that's the case, when you've been over there, just out of curiosity with
there's been some, so not any really heavy seismic activity, but there's been some studies where people have been trying to measure that. Most of the seismic activity actually takes place closer to the inner Himalayas, so far away from where we are. So in terms of the actual heavy level earthquake, those kind of things, but nothing as much where we are.
The activity. Yes, some countries have a lot more of it. I mean, New Zealand, for example, has got a lot more problems with seismic stuff, but I wasn't aware of India having so much that. No, Japan's a country that's always getting it as well. But can't recall having quite as many, but I'm sure they do have some. Okay, any other questions? Oh, okay, here we got another one. So India plans to land people on the moon 2040. Oh, okay. You're young enough, yes. Actually, I was going to make a comment. Apparently, India's didn't they have a test capsule they sent up the other day of their spacecraft? I think that was over the last. India.
Yeah, they're actually. I think it's a very ambitious timeline, to be honest. But having said that, there's different ways in which those could be achieved. There's a lot of collaborations taking place today than they were until a few years ago. So we'll see how that kind of goes along. I will obviously definitely, by all means, be interested to go to the moon. Why not? I don't think there's been any, So there is an Indian astronaut who's currently slated to fly to the ISS this year as part of the Axiom 4 flight. He's the pilot for that crew. And they are having 3 other astronauts who have been selected, and there's a whole crew of astronauts who've been trained, who are undergoing training. I do hear there's also plans to open it up to civilians to apply in the near future. So we'll see how that kind of goes.
I don't think they've made a formal announcement about that, but crew selections is going to be one of those things that they'll have to consider, I suppose. But based on the fact that they've had a test capsule go up, I'll have to go, because I only found this out literally this morning, whether or not what their plans on, but they did want to have a manned flight within a couple of years, so it sounds like that's possible now.
That's right. Actually, the program was announced, they only had 3 crewed capsule missions, but now that has been extended to 7 so that they are able to do more iterative technology demonstrations. So I think right now, if I'm not wrong, there's a crewed mission planned for next year on an Indian rocket. There's a question there about collaborating with other analog sites. So, example, Hawaii. I haven't reached out formally to them, but I think at some point we would definitely be reaching out to find ways in which there's crossovers between the different work that's happening. Certainly, all to say that the Mars Society in the US and Mars Society Australia would definitely be, looping into a lot of the conversations. In fact, they've been by having the crew at MDRS last year, and also Mars Society Australia being actively involved, I can easily see there being collaborations happening between analog missions taking place in Australia and in the US and with India as well. So,
just looking at the locations, obviously there's India, there's Australia. New Zealand's got some sites. I think there's one site that some people have done work at. There's Hawaii, as you said. I think there's Utah. And there's another one in, is it Greenland? Or is it, yeah, I think it's one up there.
There's one up in the high Arctics, in Canada.
John Clark went to, I think.
Yeah, if Mars.
Yeah, so there's only about half a dozen, I think.
Yeah, that's right.
Yeah, there's nothing in Europe because I don't think the climate's quite right, or they can't find a location. They might be able to find something up in the Scandinavian countries, I would assume, but it's probably stuff in Russia, but they're not going to get in. You're not going to get into there.
Yes, so, there's other versions of analogs which focus more on the internal training, like psychological testing and isolation testing and those sort of things. I know that in Europe, they certainly have been doing some of that, and even in Antarctica. So there's different versions of analog campaigns that could be run.
Yeah, I mean, the real thing to note there is that the analog in India is because the actual geology, there is a similarity in geology to Mars as well, certainly. Same with Australia.
Yes.
We start going to, say, in the Arctic area, that's really more because it's harsh, not necessarily because you've got the rest of the climate's the same. So there is a bit of a variation, as you said, as what they're looking for in the analogs. So, but there's not that many locations across the world now, and obviously the Indian one's becoming more important because we've been able to do more things. We've got more people involved. As you said, there's the people. You've got infrastructure in place that's supporting it. And that's why.
Yeah, and also in terms of the level of activities being planned and missions being planned, I think because India is one of the few countries that has a lot on its plate right now, at least in front of it. Given how things have been going in the US and Europe, all to say that it's going to be a bit of a hotbed of activity in India, and that also might lead to more encouragement, more support for researchers to come in and do that level of work as well. So the way we'd like to set it up is it'll be open for international people to be able to come in and utilize that space.
So have we got any more questions? Well, if that's no more questions, I would certainly like to thank you very much, Siddarth, for your time explaining things. I learned a lot tonight, actually, about what's going on. They're quite interesting. So,
thank you so much, Wayne. Thank you for the opportunity, and it's always a pleasure to speak with the NSSA. I was a benefactor of one of the student grants back in 2017 to attend the IAC in Adelaide. So I do owe the NSSA a lot to my journey through this career.
Well, I think I've known you since about 2015, since I met you when you were doing your doctorate down at ADFA, I suppose it was.
That's right.
As they call themselves now, because I think they've got a more formal title. But yeah.
That's right. Yeah. No, happy to speak with you guys, and look forward to continued collaborations and giving you an update as we go along.